You give your AI coding agent a command, step back, and watch it spin. It tries, fails, hallucinates effects, and tries again, burning through tokens in an endless loop without ever actually completing the job. The problem usually isn't the AI's capability, it's the prompt. To fix this, we have to transition from providing subjective instructions to building an objective, verifiable finish line. Before we build that finish line, check your terminal. This specific workflow requires you to have Claude Code version 2.1.139 or higher installed. Once you have the right version, you can delegate execution power more effectively. Setting a mathematically strict goal allows you to quantify progress and cap costs before the agent begins its work. Look at a typical instruction. Make me some marketing content. In a standard chat window, this gets you a polite, generic response. In a terminal environment where an agent is trying to execute code and write files, this instruction lacks the boundaries needed for success. This graphic maps out a solution, the 5-part goal brief, providing structural requirements for autonomous execution. Step 1 is the task. Look at the example prompt. Instead of make content, it says create 7 ready-to-publish posts. Tell Claude exactly what to do. Starting with a quantified, specific action prevents the AI from having to guess the scope and volume of your request. Next, we move to column 2, the purpose. The AI absolutely needs to know the underlying reason for the task. When Claude Code operates autonomously, it will inevitably hit a sudden roadblock, a missing file, or an API error. If it understands the goal, it can make micro-decisions to bypass that roadblock without stopping to ask you for help. Then define the output. You have to dictate the exact physical file or artifact that should exist at the end. In our example, the instruction demands one content calendar. Defining both the purpose and the output ensures the agent targets a specific format, which reduces the need for manual cleanup once the task concludes. But even with a clear task and output, launching a goal command without boundaries is risky. An unconstrained, boundless AI agent can spend significant time and tokens endlessly trying to perfect a single function. That's why column 4 establishes guardrails. You have to set limits on scope and cost. In the example, we give it a limit. Stop after 5 turns if blocked and list the remaining gaps. Look at the dark blue banner in the center. A common mistake is asking Claude to keep improving. This prompt is too subjective to be verifiable. Instead, you must provide measurable criteria that signal the work is complete. You do that in column 5, proof. Look at the green highlighted text. We create a done when checklist. Done when all 7 posts pass a green checklist, fit character limits, and contain no unsupported claims. Embedding a self-verifying checklist gives the agent a logic-based exit condition, allowing it to signal completion independently once specific criteria are met. When we look at them side by side, the difference is clear. We've moved from one vague line of text to a structured, objective set of instructions. Now, when you hit enter in the terminal, the process is streamlined. Claude iterates on the code, hits either the goal or the turn limit, and checks its own work against your proof checklist. Save the 5-part blueprint graphic we just reviewed and use it as a checklist before executing any complex goal command. This structured approach provides the necessary control to use Claude Code as a reliable, autonomous engineering partner.